Hey there, good day, good morning. How are we doing? Today we'll be building a very interesting model with LabelCraft. Let's just get right into it. So I'm going to create my project. I'm going to call it a brain tumor detection model. That's what we're going to be building today. A model that can actually detect tumor in a brain CT scan. All right, let's give my project a name and let's give it a description. This is a project to train a model to recognize. Okay, that's a mistake. To recognize a tumor in a brain CT scan. Voila, let's create our project. Okay, now we're going to click on LabelCraft as a tool, and yeah, we are on the LabelCraft dashboard. Let's create our tags. So I'm going to create two tags actually. Tumor presence. I'm going to give the red sign to detect that danger, and tumor absent. I'm going to give that let's give that a green color. Yeah, let's give that a green color. Always make sure you put colors when you create your tags. They're very important. Okay, now let's import our images. So I have this very interesting data set on brain tumor CT scans where it classifies it as the scans that have tumors. As you can see, the yes, I'm going to pick about, let's pick about 10 thereabout from here. Then I'm going to go and pick some other clearer scans without the tumor as well. And we're going to pick about that number from there. So let's just go from, so that's from the yes, the folder. So I'm going to go back to the no part of the folder. I'm going to pick some other ones from there as well that are also clear scans. And we're going to get right into the build process. Okay. All right, so let's upload. So now you're going to notice that the images keep dropping on the background. This is an indication that those images have been uploaded. So you're going to see that behind, when I click on upload, those images are dropping. So that's an indication that those images are being uploaded properly. Yes, that's it. Okay, and our images are going to be uploaded. Voila, and there we go. Now let's get right into it. So I'm going to click on the first image. I'm going to bring it to the main dashboard. Now you notice what I'm going to do is, what I clicked on is the bounding box just to create. So I'm going to zoom in. Now that's a tumor. You can see those whitish part. I'm going to use the hand tool, the other one, to make the box active. This is so that I can attach a tag to it. Now I'm saving immediately. Now one thing you don't want to do is you want to be saving your images as frequently as possible as you annotate across those images. And like I already did, now I'm going to pick another part of that image where there is a clearer part of it. So just annotate as the absence of tumor, right? And I'm saving again. Now you can see best practices as frequently as possible. Make sure you save. Now that's another interesting image. So when I click on the quick page, it just brings another image, another image, another image. It makes it very seamless. One page per image. However, multiple annotations can be done like you already see me do. Okay, now this is interesting. So I want to pick another part of that image. The tumor is a little bit on the large side, so I want to annotate multiple parts. This is also to give my model enough information about what tumors can look like on the scan. A little one in here though is I am training my model with very minimal images, and this is not best practices. It's just for a demo sake. When you're working with models on things as sensitive as medical, you want to train your models with as many images as possible. This would definitely affect my accuracy when I'm training, just heads up. But I just want to use this to explain, when you're training your own model, you want to use a lot of images, and as much as possible. I'm talking 50, 100, 150. This is really important. Okay, so just a note. And well, let's keep annotating. And even on the scans that have tumor, I still am able to differentiate between what that tumor looks like and what it doesn't look like. Yeah, I know I have a CT scan that are clearer, which I already uploaded, but I just wanted to have as many descriptive way of representing the absence of tumor as possible in my model, which is why you see me do this. And look, notice that I'm also saving as frequently as possible. This is very important. This is so that, oh, this is a clear scan. Now, okay, there's a tumor on this one. Okay, the tumor on this one. You see that whitish part below? That's a tumor. So we're gonna annotate that. You're good. So remember, as I said, you want to make sure that every point in time you are what's the word to use now? At every point in time you are annotating properly and you're saving properly and you're giving your model enough information on how these things can look. One interesting thing I learned is I actually learned that scans across regions for people in the Caribbean, for people that are Hispanic. These scans are different across regions. Across regions, when I say regions, I mean the images. My point here is if you're building something for a more robust system, you want to get as many images across various cultural areas as possible. This is so that your models can predict across regions. I heard this at some point. I read a medical journal that mentioned that scans can differ from regions to regions, and this is just to let you know that this is also another way to make you understand that you should have as many images to cover for that cultural gap as possible when you're building your vision models. So let's just keep annotating, and you can see, make sure you use your hand tool. Your hand tool, without your hand tool, when you annotating means when you create your bounding box, you won't be able to give it a tag because your hand tool makes the annotating box very active, such that you can now add a tag to it. Very, very important. Okay, that's another tumor, so we're going to annotate that as well. Second, I want to take, okay, that's another tumor on the edge. I want to also take that part as well and also annotate it. This is just to, like I've always said, give my model enough information on how these things can play out. Oh, this is huge. This is a huge tumor. Okay, you want to also, can I pick all at once? Okay, I should be able to do that. Also, another thing is I don't want to pick the tumors and pick a part of the clearer part of that scan. This could be an issue. So you want to be careful. If for what I'm currently doing, if you can't pick all the tumors once, I can do annotations on multiple times. So you want to pick them little by little. It's allowed. You could do that, right? Because you don't want to confuse your model that the same things are happening twice. So this is another very huge tumor as well. I think I might have picked a part of it where there isn't a tumor present. Okay. Now you see that I'm trying not to pick where those tumors are alongside where those tumors aren't. This is because I don't want to cause confusions for my model. Well, this is a clear scan. Now this is very first clear scan. Like I've always mentioned, make sure you save as frequently as possible. Well, now I can pick a lot of sites here because this scan is pretty clear. It's a pretty clear scan, so we can pick as many sites as possible here. Okay, I want to pick one more site as well here. The scan is really clear. Okay, let's just pick more. All right. Yes, there's absence of tumor on this scan, so I have the flexibility of picking across a lot of regions, and I like this, of course, just to give my model. So basically all I'm doing is I'm trying to give my model enough information and enough insights to work with. Now if you are trying to annotate, right, just a little heads up as well, if you're trying to annotate and when you click on the toolbox, the hand tool rather, it doesn't pick the box. You want to try to refresh your browser. I've experienced this sometimes when I try to, it could be your network, it could be your internet service. So when you click on the bounding box and you've created your bounding boxes, and you also try to use the hand tool and the hand tool doesn't pick the box to add your tags, you want to try and refresh your browser, but make sure you've saved prior annotation so you don't lose all that. Which is why I'm mentioning best practices is at every point in time, make sure you save. Another heads up you want to also know is if you use a Brave browser, you might struggle to annotate your models right now. So you want to use your conventional browsers like Chrome, Edge, and all of that. Okay, so let's keep annotating. Absent, yeah. save. Always save when you annotate. This is very, very important that you save. All right, let's keep annotating. This is actually very interesting. So basically what we've done at Autogon is we simplified the process of building vision models to three major things. Get your data sets as to images, create tags, annotate. That's all. Now this is that route that we've given, and we'll build some very interesting industry standard models via this route. We'll build models that can detect some very interesting diseases in plants, and this is industry standard with enough info. Okay, let's check the stats of what we've done so far. So apparently I have annotated 12 tumor present and 16 tumor absent. This number is not really large enough. I think I have to balance this at some point because tumor absent is currently winning tumor present, right? All right, let's just finish annotating all the images I have. I might have to go import more images from the tumor present part of my data set. Okay, now let's annotate this guy. Okay, this is a clear scan. Tumor absent. Good. Now let's save. Remember to always save as much as possible. I mentioned that like a lot of times in this video. You want to make sure you listen to my instruction. If you do not save, I'm going to come hunt you when you lose your project. Okay. Yeah, tumor absent. This is really nice. Let's keep saving it. And I think on the last image, I think I imported about 20. Let's just see this guy. Okay, tumor absent. This is nice. Okay, so 20 to 12. No. I need to make tumor present up to that level as well. So that's just going to take tumor images from the tumor present part of my data set. Let's take another 5. Okay, let's take another 5. So when we take 5 more, we can use that to get a bit more of the tumor present part of it. Okay, I'm going to upload it. So I'm also going to actually attach the link to the data set that I used in the description of this video. So what that means is it's a lot of scans. You have more images to work with, and these applications you can already do things around agriculture. We can do this around detecting plant diseases in plants, and you want to even be more descriptive about the name. Look at the naming convention of what I did here is I just did 2 things: tumor present, tumor absent. This might necessarily not be the convention that works for you because tumors can be a lot. They can be different kind of tumors, even in the brain and across the body. So you want to be more specific if you are a medical personality, and then you want to have those tumors with their names. But also in the cultural space, you want to also build tumors, you want to build models rather that can detect specific diseases across various plants, even in animals. Say chicken, you want to detect a particular kind of disease, and you want to build models that can do that, right? This is also applications of vision models and agriculture, even in the oil and gas space. You want to detect some very interesting problem statements in that space as well. These are applications, industry standard applications that I already see where you can build interesting stuff, as you already see what I currently do, and I want to really see you do interesting stuff around those areas. And let's change the world with AI, and let's change the world with the power of automation. All right, let's get back into our work. So yeah, we'll be annotating while I gave that short lecture or speech if you like. All right, let's keep annotating. Okay, my answer isn't picking. Remember I said earlier on that if your answer isn't picking, you want to try and okay, let's undo first. Okay, let's try again before I even refresh the browser. I want to try that. Oh, it picks it. So even you don't have to refresh the browser. Sometimes you just need to undo and try to use the answer once more, and then that should work and solve the problem. Oh, if you look at it, I'm getting there, right? Tumor present has 18 annotations and tumor absent has 18. Oh, we're getting there. Okay. All right, let's keep it going, and let's save. So I'm just going to get it to 20. I think at 20 I'm good, and we're just going to train. Yeah, this might necessarily not give us so much about just an accuracy. because I'm working with a very small number of data. So I'm not going to do that. I'm just going to keep it. I'm not going to keep it at 2020. I think I'm good with 2020. This is enough. I'm just going to train my model with this point, and I'm just going to work with this now. Let's let's just leave it at this, and this should work. It should work. Yeah, this is not exactly the most. This is not the most optimal way to build intricate models like this. You can have one unannotated image. Oh, good. So if you notice, I might have created a bounding box and not give it the right tag. Now, this would be a problem because when I now try to train my model, I get an error around things like you would see something called image annotated LBO. So you want to watch out for that, right? Make sure that every bounding box you created, you gave it the appropriate tag. This is very important. So I just came back here to check, and I had a feeling that I did not annotate this particular scan properly. And this is very important because I won't be able to train my model. I'm going to get that error flag. Make sure that every bounding box that you've created or you create always does have its own what's the word to use now, its own tag. It's very important that every bounding box that you create, so I'm just going to check through now so that I'm sure that every scan I have worked with has its own what's the word, has its own tag. This is very important. I am going to come into errors if that is not done and is not done right. Okay, let's just check through and everything is good. Now let's train. Oh, good. Our load name is an override name for an existing model if you want to change the name. Our new name, so we don't have to override because it's a new model, so I want to give it a new name. Now, the epoch level basically is, if you increase the epoch level, what it just does is it checks for more intricate patterns in your model. You don't want to increase it so much because your model might overfit. And of course, I already dropped the description on the beginning of this video, so you want to check that properly. So we'll just give it a name and we're going to just keep on train. So we're going to queue on for a bit, and in some minutes we're going to get to, we're going to change this queuing to train, and from there we're going to see how long it's going to take us to train this model, right? And like I mentioned earlier, when you're adjusting your epoch level, you want to be very careful. The idea of epoch level basically is trying to check for more distinctive patterns in what you're trying to check for, as to what's the word, as to models and what you're trying to detect exactly. However, you want to be careful. I left my epoch level at 8. You want to keep it, you want to, I mean, it's left to you really on how you adjust your epoch level before you train your vision model, but you want to make sure that you are not overshooting that epoch level, because it could make your model overfit, and you don't want your models to overfit, because overfitting your model also means that it is highly prone to errors, and you don't want that for your model, right? So this is one thing you also want to look out for as you build. But however, I left it at 8 because this is just for demo sake. I'm going to be mentioning all of these things while you watch out for it while you're building your own model. This is very important that you note this. This is very important that you note this. So we're going to keep training, and let's see how long it takes. Like I mentioned, we might not get some very interesting accuracies here, and the very interesting factors to that is like I mentioned earlier, the number of images that I'm working with, it's pretty minimal, and also the number of images are minimal. Now epoch level isn't really on the high, but that's not really a factor though. It's just basically the images I'm working with are very minimal, and so we might not be able to do those predictions right on call, but I'm going to show us how that will be done, and how you can do that on your own. Also, you want to also look at, you could even augment your images. If you click on that icon beside training, this icon, you'll see some very interesting options like augmentation. When you click on augmentation, you can do some interesting edits around your model images, and you want to already try that on your own. I mean, play around it. So you can even check the documentations. You can now run predictions by postman if you are a technical person. So I'm going to also be adding the docs link to the description of this video. You want to also check that as well. This is very important because let's say you built the model in stress and accuracy, you now want to interface with it via API. Of course, you can always do that. You're going to see the description of how that can be done on documentation, and of course you can also drop questions in the comments, and definitely someone is going to respond to that question, and that person will be me. Or maybe not me, but most likely will be me. So yes, we're going to check how long it takes us to train, and I always encourage that when you train a model with Autogon AI, try and share it with the world, try and share with people, let us know that you built something with Autogon AI. Let us know, share with us. You're going to see very interesting confetti pop up. This is so to infuse that energy. Ooh, like I said, can you say my accuracy is pretty low, 60.8, but like I said, always share your model with the world. You can already click on Twitter, share, tag us, let us know you built a model that can actually detect the brain tumor in a CT scan. This is interesting, but I'm not going to share my model because this accuracy isn't really good, but this is just to show you that. Now let's check the stats that we have. Now, like I showed you, let's check the metrics. Now these metrics are metrics of the models I've built based on the epoch level and number of images. You want to learn more about each of them, you want to click on the learn more part. It shows you all of those things are the F score, the recall, the mean average precision, all that. Now, like I mentioned as well, I'm going to teach you how to use the imports, work with YAML file and all that in subsequent videos. But for now, I just want to show us so let's just test. So this is run test model. So click on that. That's like how you do a prediction with your model. So let's just take one image. I honestly that I'm going to get a good prediction because the accuracy is pretty low. Like I said, I'm not shocked. It's not going to give us some very interesting predictions. So, however, all things being equal, if I train this with proper amount of images, these tags are going to get some very interesting JSON responses, something of that nature. And you want to also look at the conf tag in that response and check the percentage of that. This is to show you the accuracy of how sure it is that that tumor is present in that scan, and you want to adjust your confidence threshold to accommodate for more predictions. This is, I mean, your confidence threshold is like saying that you want to allow for a minimal amount of error, a little bit more amount, something of that nature. This is just to show and detect all of this. But like I mentioned earlier, I exactly didn't train this model with so much images, so that explains why this prediction is not happening. But like I mentioned, you don't want to make the mistake that I did. And this is how to build a model with Autogon and LabelCraft. Thank you for joining, and I can't wait to see what you build with the Autogon platform. Bye bye.